All right, finally, we are going to begin. Welcome, everybody. Does anybody have any questions for today, March 7, on what we did? You have any issues that we need to talk about first? Hello? Are we there?
Yep, I don't personally have any questions, though.
All right, okay. So hearing none, hearing no questions, today we are going to move forward and advance our understanding of applied statistics. And so what we are going to talk about today is introduction to regression analysis. Introduction to regression analysis. So let's see how we begin our introduction to regression analysis. Okay, so I'm going to share a document with you. I'm going to pull up a document to share. All right. And this is an introduction to simple linear regression. Okay. So, and before I get to explain, before you ask me what is simple linear regression, regression analysis in general is a statistical procedure where we relate variables to others. Okay. Essentially, what we have in a regression analysis is that we are all along we have been dealing with a single variable. For example, the size of a house, the amount of living space in the house, that's a single variable. The age of a population of students, the average distance that people travel to work, that is one variable. But the point of the matter is that the average distance that people travel to work, or the average amount of time that it takes people to go to work, could depend on a number of other factors, a number of other variables, to say it in statistical language. It takes you 20 minutes to arrive at work. It takes me 25 minutes. It takes him 30 minutes. It takes her 45 minutes. Why? Why is it that everybody does not arrive at work at exactly the same time? And so the average time that it takes you to arrive to work depends on. So the average time that it takes you to arrive at work is called a dependent variable, because the time, whether it is 20 minutes or 25 or 35 or 45 minutes, the length of time that it takes you to arrive to work depends on what? The distance between where you began and where you're going to work. So if you live 15 minutes, if you live 15 miles from your workplace, and I live 25 miles from my workplace, from the same workplace, then chances are it will take me a longer time. The amount of time that it takes you to get to work could depend on the mode of transportation, the mode of travel. If you live 2 miles away from the workplace and I live 2 miles away from the workplace, and you take a bicycle, and you ride a bicycle to work, and I walk, or somebody else takes a cab, okay? So the mode of transportation is what makes the difference. The time arrival to work is dependent on the mode of transportation. And so the time that it takes to get to work is called a dependent variable. And those factors or those variables that affect how long it takes are called the independent variables. Okay, so you ask yourself, the grade that you got on an exam depends on how long that it took you, how long you studied for the exam. That could be a factor. Okay, so you can go on and on and on. All right. The price of a house depends on the size of the house. The price of a house, the dependent variable, depends on the size of the house. And so the value of the dependent variable depends on the value of the independent variable. So the values of an independent variable do affect the values of the dependent variable. Okay. So now when we then say simple linear regression, this is the beginning of our understanding of regression analysis. Simple linear regression is where you have one dependent variable and one independent variable. Now, if you were dealing with one dependent variable that is the values of which are affected by two or more independent variables, then we're dealing with multiple linear regression. And now we have also more complex models of regression analysis that we call multi-equation models. Okay, we're not going to go into that in this class. We used to be able to do it, but no, not in this class. In econometrics, if we were taking econometrics Econ 474, which we have taught a few times in the past, then we go to multi-equation models, okay, and all kinds of complications. So we're not dealing with that. We're not going to deal with that in this class. So let's now go back, at least begin with simple linear regression. In about 2 or 3 more weeks, we'll get into multiple linear regression, okay, and a few other complications of multiple regression. So in a simple linear regression, our objectives will be to apply regression analysis to estimate the linear relationship between two variables. Okay, we will also evaluate the significance of the slope of the regression equation and evaluate the regression equation's ability to predict using the standard estimate of the error and the coefficient of determination. For this class, we will focus on the coefficient of determination. Okay, I'll call it what it is. It's R squared. Okay, the coefficient of determination is called R squared. All right, so let's try to motivate our point. Okay. All right. We have a relationship between two variables, y and x, and the dependent variable is y. The independent variable is x. Okay. Our first step is to determine the nature of the relationship. Nature. What is the nature of the relationship? Is it negative? Is it positive? Or there is none? Okay. And when we say negative, for example, in economic analysis, we ask the question, what is the relationship between quantity demanded and price? the higher the price, the lower the quantity demanded. And you know that, the law of demand. The higher the price, the lower the quantity demanded. So when the price goes up, quantity demanded goes down. So that is an example of a negative relationship. Now, what is the relationship between the price of a good and the quantity supplied? When the price goes up, the quantity supplied goes up. So that is a positive relationship. Okay? Now, what if the price does not make any difference? Okay, so there's just a fixed quantity demanded, no matter the price goes up or down, folks will just buy or sell the same amount. So there is no relationship. I often illustrate this by asking a simple question. What if you stand on the intersection of Bedford Avenue and Crown Street? If you stand on that intersection and count how many vehicles cross that intersection every hour. So every hour on the hour, you write down 10 vehicles pass, 15 vehicles pass, 20 vehicles pass. And exactly on that same hour, you count how many newborn babies are downstate medical center. And if you do that, you will find out that there's no relationship. Now, maybe if you stand on the intersection of Bedford Avenue and the street on downstate, maybe by the maternity area, maybe the number of vehicles you see there in an hour will give you an idea of the number of babies. The number of vehicles you see there every hour will give you an idea of the number of babies born. Okay? But not on Bedford and Crown. All right. So after we determine or estimate the nature of the relationship, is it positive, is it negative, or do we conclude that it's not, which we will talk about how we do that. We also then talk about the size or the magnitude of the relationship. For example, if the price goes up by $1, then quantity demanded will decrease by 5. Okay? That is a size of relationship. So you're looking at, say, a number like 0.2. So we have estimated also the size of the magnitude of the relationship. So then the other thing is, how strong is the relationship? What percentage of changes in dependent variable is explained by changes in the independent variable? Now, for example, we raised a question earlier. The time it takes for you to go from your origin to your job is explained by, for example, the level of congestion along the road. It's explained by the distance between where you live and where the job is. But the point of the matter is that the distance alone could just explain 10%, or you could explain 90%. Could just be that the distance alone explains 90% of how long it takes you to get to your job. Okay? For example, we raised the question of the price of a house depends on the size of the house. But it could also depend on the size of the house. It could depend on the neighborhood. It could depend on the size of the land on which it was built and what have you. And so then the size of the house alone might just explain 60% of the price. And these other factors, maybe some of them unknown, explain the balance of 40%. And so for our level, we're going to just look at these three aspects: the nature, the size, and how strong. Okay? What percentage of changes? And this is why we call this is what we call the coefficient of determination. This is what the coefficient of determination tells us that. Okay? All right. So let's then proceed again, trying to lay the foundation for a thorough understanding of our topic or subject. All right. So now regression analysis is done using what you already know in algebra, the equation of a line. Okay? You use the equation of a line to do regression analysis. And that equation is based on what you already know. Y is equal to A plus BX. Okay? And B, this is B times X. Okay? B times X. So A is the constant value, B is the slope, and of course, X is what changes. Okay? B is the slope or rate of change when X changes by 1. So when X changes by 1, which is the independent variable, Y, the dependent variable, will change by B. And here's an example. Suppose you have a positive relationship where Y is equal to 10 plus 5 times X. This is a positive relationship. Okay? And so, for example, if X is 3, then Y is equal to 10 plus 5 times 3, which is 25. Now, for a negative relationship, is Y, if Y is 25 minus 2X, 2 is the slope, which is the rate of change. And so if X is 3, Y is 25 minus 2 times 3, which is 19. Okay. So, but we are dealing here with a perfect relationship. The equation that you see here is a perfect relationship. Now, in this, if you have a perfect relationship like this, then regression analysis doesn't help you in any way. Just doing mathematics. And you're going to learn that by taking calculus and other higher levels of mathematics. Okay? So you're assuming here that you have a perfect relationship. And so the illustration here is just to show you what we are going to be dealing with. Y is equal to A plus B times X. Okay. Like I said, an example of a linear relationship is the size of a home measured in square feet and the cost to heat the home in January. How does the cost vary relative to the size? Let me rather say, based on the size of the home. The amount of money you spend to heat your home depends on size. So the amount of money you spend to heat your home, which is the cost of heating the house, which is the dependent variable, depends on the independent variable, the size of the house. Okay. For example, in a study of automobile efficiency, assuming a linear relationship, the miles per gallon depend on the weight of the car. If your car is heavier, then it will consume more miles per gallon. I learned this the hard way many years ago in 1980. And I made a budget to drive my car from North Dakota to Pennsylvania. And lo and behold, I went to U-Haul and hitched a trailer onto my car. And then usually my car would run 275 miles on a full tank before I want to fill the tank, actually on a 3/4 tank. And so by the time I drove 150 miles, the gas was gone. And I said, what's going on here? And I went underneath to see if my gas tank was leaking. My gas tank was not leaking. Okay, I filled up my gas tank again. And another 150 miles, the gas was gone. Well, I was not informed. So I went to the next gas station and I said, what's going on? I asked the mechanic to look under my car and say, is there anything that I'm doing wrong? I said, but you have that trailer hitched into your car, or hitched onto your car, and so that's why it's taking up more gas. Oh, well, I should have known that. Okay, so you can see here that if you were looking at the distance traveled and miles consumed, the amount of gas consumed depends on the distance you travel. But then the distance you travel is not the only thing that explains the amount of gas consumed. I learned the hard way that the weight of the car that the car is pulling also is a factor. Okay, but that is something that you learn from multiple regression. But the distance alone does not explain all of it. Okay, so the regression equation is going to be y is equal to a plus bx plus e. So for a regression equation, it is the variable used to estimate the dependent variable. Okay, that is the independent variable. And then in a regression model, we have to add e. And e represents error because the relationship in a regression model is not perfect. This is why I said, then let's introduce imperfection in the relationship. There are errors, okay? Now, besides if I had not hitched a trailer onto my car, 10 different people could be driving the same distance and they all use different amounts of gas. For the simple reason that we're going to be driving on different roads. We're going to be driving in different, I would say, driving behaviors are going to be different. Okay? If I stop frequently and restart my car more frequently than somebody else, then I might end up using more gas. Okay? If the roads is bad, that's one factor. And so different road conditions. And so if we don't measure any of these, then for all intents and purposes, there will be differences in the amount of gas that we use on the same distance. All right, so then what is our objective in regression analysis? Since, like I said, we add this E to the perfect equation. Now, the perfect equation does not include E. Just y is equal to a plus bx, okay? But once we introduce randomness, that is what we call stochastic in statistics. Once we introduce randomness, then we introduce E, which is an error. And so the only thing that we can achieve using regression analysis is to estimate the true, A is the true constant, B is the true slope. But because we are using statistical data, we can estimate A using A hat, and we estimate B using B hat. Okay, those are estimates. And in order to do our estimation, we use data sets. Okay, for example, the quantity of copiers sold depends on the number of sales calls. Essentially, we are saying that the more calls that a salesperson makes, then the more copiers they sell. Okay, so copiers sold is the dependent variable, and the number of sales calls is the independent variable. And our methodology for this is going to be called the ordinary least squares principle. The ordinary least squared principle. As you can see from the diagrams here, you can see the relationship between the dependent variable y and the independent variable x is not perfect. And so our objective is to draw a line perfectly in the middle of the scatter plots. What you have here, the dots that you have here are called scatter plots, like something that is scattered all over the place. But what you see is that there is a tendency. The relationship is not perfect, but there is a tendency. And you can see in this case, the tendency is positive. The more sales calls, the more copiers sold. And so our objective is to draw a line perfectly in the middle of this scatter plot. And we achieve that by using an estimation process called ordinary least squares. And in order to do that, we use an equation, okay? Now, I have set up this data set, and I'm going to switch, okay? I'm going to take this out, and I'm going to put it in the right place. Okay, so we use this equation. We use the equation here, the ordinary least squares formula, okay? Now, in order to estimate the equation y is equal to a plus bx plus e, we transform the data. We have to transform the data, okay? We have to transform the data, and we use, now, you do not know yet how to derive the equation. If you were doing the Econ 474, you will learn how to derive the equation, or maybe even not, okay? All right, but if you solve this equation the way it is solved statistically, this is how you estimate the B hat. That is this B, this is how you estimate it. And the A hat, this is how you estimate A hat using Y bar times B hat times X bar. Now, how do you then derive these numbers that you use? Okay, that is, how do you obtain this? How do you estimate B hat using this formula that is here? I'm going to use the data here. So I'm going to pull up an Excel file to show you how to do that. Okay. All right. Now, I'm just going to take you through the exercise, but in an exam, I'm going to do the calculations for you, and you simply plug in the formula. But I'm going to show you how we get these numbers. In that way, you will not just think that the numbers come from the air or come from some magical process. The process is tedious, but it is not something that you are not capable of doing. Okay? Uh, so let us see if I can pull up some data for you. Okay, I'm going to share. All right. Now, this is the data on sales calls and the number of copiers sold. Okay. Now, you remember the formula. Okay. Remember the formula. The formula, let me see if This is going to help. Let me get the formula. Let's see if we're going to be able to paste the formula here. If not, all right. We're not able to paste the formula, but from the illustration, from the formula that we saw earlier, uh, let me see if I can pull it up again and just remind you of it. So here is the formula. The B hat is estimated by taking the summation of x minus x bar times y minus y bar divided by the summation x minus x bar squared. So that means that you must calculate x bar, you must calculate y bar, and then you must calculate x minus x bar times y minus y bar. And so how do we go about doing that? Okay, so I'm going to pull up the Excel file again and show you what we are going through. All right. I'm showing you. I'm going to pull up the Excel file. All right. So first of all, we must calculate x bar, which is the average value of x. The average value of x is equals average. The average value of y, the dependent variable, is 45. And the average value of x, the number of calls, use the same formula, and we get 96. Okay? Then we calculate y minus y bar, and then we calculate x minus x bar. Okay? So that means we take the value, each value of y, and subtract it from its average. So for each of the values here, we subtract each value here from its average. The average of y is y bar, which is 45. And so easy, we take equals C5 minus $C $20. Okay? But C5 minus $C $20, which is this C5 here, which is 41, minus Okay, I'm sorry. I was trying to shut off a phone call. All right, so now we subtract, we take 41 minus 45, which is minus 4, and we take it down. All right, as you can see, if you subtract each value from the mean and you sum those, what you're going to get is a 0. Okay, we do the same for this, which is D5 minus $D, $20, and 96 minus 96, this D5 minus 96 here is going to give you a 0. But when you pull down to the end, you also, all right, if you do it correctly, yeah, minus D5 minus D5, I'm sorry, D5 minus $D, $20. So this is the average here. Okay. See, it has to come out correctly. Good. Sum. All right, we get 0. And so now we take YB, that is Y minus Y bar, okay, which we call YB here, Y minus Y bar, and we square it according to the formula. And so will be equals E5 to the power 2 okay, and we'll sum it, we'll get that number. So equals F5 to the power 2 okay, and then we then multiply Y minus Y bar times X minus X bar. Okay. We sum that, that's what we get. And so when we apply the formula that we have there, you find out that B hat, the estimate of the slope is 0.261. A hat, the estimate of the constant is 19.98. We did not get to R squared yet. We did not get to the formula for R squared. And so our first step in doing a regression model is already taken, it's already complete. And so now I'm going to also stop sharing this and then pull up the original PowerPoint slide. Okay, so now you can see we have the same results, 0.261 and 19.98. We got exactly the same results, and the numbers are here. I'm going to post both the MS Excel file and the PowerPoint slides, so you can corroborate what we did. But the very first step in regression analysis is to do what you call a scatter plot. Now, the scatter plot will give you an idea of the tendency of the dependent variable as the independent variable is changing. Okay, this is what you have here. You see here, you have the scatter plot. The scatter plot shows you a tendency. And like we said, our objective is to draw a line smack in the middle of that tendency. So I'm going to pull up the Excel file so that you can see how to do that, because your first assignment for this class is going to be to draw the scatter plot and interpret it. Okay, so I'm going to show you how to do that so that when we come next time, we're going to spend a lot of time on the estimation, and then I'm going to also illustrate to you how to read off that estimation from an SPSS file. Okay, so let's see what we can achieve with that today. All right, so let us see if we can do a scatter diagram. Okay. All right, so now how do we do this scatter diagram? Essentially, you have your calls and your sales. The calls, the sales, how much you sell, which is the dependent variable, is Y. Okay, that's the symbol we have for it. And the number of calls, the independent variable, is X. So how do you do that? You go to data. Go to data. Let's see. No, I'm sorry. You go to insert because you're trying to make a chart. You see where you have charts here. Are you seeing the charts? Hello?
Yeah. Yes.
Okay. So you click on that. Okay. And you click on that. Okay. You have nothing. Okay. So because you did not identify any variables. Okay. So now you have to be careful. It depends on how you paint this. You paint the two variables, X and Y. And so you insert. Now, do you see what you have? Okay. I'm going to move the chart. You can see, before I move the chart, you can see the tendency. So what would you say is the relationship between calls and sales value? Is it positive or is it negative?
Positive.
Positive.
Positive. So that means the more calls you make, the more sales you make. Is that correct?
Yes.
Good. So you have a set of problems in your homework. I want you, first of all, to go and look at the data set and complete the assignment so that I know you know how to interpret the scatter diagram. I know that you also know how to anticipate the sign of the slope. Once we do that, then next time we're going to go spend the entire hour looking at how to manipulate the equations and the numbers to come with an estimate. And after that, we will also then test a hypothesis, okay? I don't want to pack all of that into anybody's head tonight because it gets quite heavy. So if you have other questions, you ask them, and then if not, then go and at least show that you can interpret a scatter diagram. Is that a deal?
Yeah, quick question, Professor.
Sure.
Just looking at the chart that you have up, it should be reversed though, right? Like the bottom right here is the y-axis, right? And the y-axis. So
and the way to reverse it, to answer your question before you even ask it, let me move that to chart 1. Okay, I'll go back to the data. Okay. If I move it to chart, you can see it kind of gives you a clearer picture. But let me answer your question. Now, if you want to reverse it, what you need to do is to essentially copy this, put it over here, and then put the cells on the left side. So let us see if you get the same results. You insert, do that, you get the same thing. Sales here and number of calls there. But you can see you get the same thing. So the whole idea of looking at a scatter diagram is that essentially it just gives you the same tendency. It may not matter depending on the way the variables relate to each other. It may not matter which side you go, okay? But if you get a distorted set of scatter plots, reverse the order and see if you get something that is clearer to you. Is that clear?
Got it. Thank you.
Okay.
Professor.
Yes.
For the homework, you just want us to interpret in terms of if it's positive or negative?
That's it.
All right.
I want you to get that point.
Do you want the straight line too, or just negative?
No, you don't have to draw any straight line. Look at it and give me an interpretation.
Okay.
Okay?
All right.
Okay. Any other question?
Yeah, but we do have to show the graph, or we just saying if it's positive or negative?
You have to show the graph. You have to show me the graph.
Okay.
Okay? You have to show me the Excel file, and if possible, if you have the energy, copy. You can take this, copy it, and install it on I'm going to stop share for a moment. And they can paste it on a MS Word file.
Okay.
Okay. And
just have the interpretation on under it, right?
Yes, you have the interpretation under it, or you can just do it on MS Excel. But if you do it on MS Excel, please move the chart. You can see I moved the chart. You click on move, and that's it. You don't have to do anything magical. Just click on move, and it will create a separate sheet that shows you just the chart because it's clearer. You get it?
Yes.
Okay. All right. Any other question? All right. Hearing none. It was nice seeing all of you again tonight. So please be sure to be here next week so we can talk about how to do the estimation. I already showed you how to do the estimation, the equation of the line, and you can see it's pretty easy if you can plug in the numbers, and that would be that.
All right. Thank you, Professor. Good night.
Good night.
All right. Thank you.